Today's lesson is on graphing systems of inequalities. If you haven't already printed off the video guide, go ahead and pause the video, print the video guide, and then come back so you can do the examples with me. Now, in our previous lesson, we graphed systems of equations. And for systems of equations, we talked about how a system is two or more equations that you are solving at one time. And we found the place where they intersected, so that was the spot that they had in common, and that was our solution. Now, systems of inequalities, is very similar. All right, for a system of inequalities, we will have two inequalities that we will be graphing at the same time, and we are going to find the space that they have in common, and that's going to be our solution. Okay, so let's go ahead and try example number 1. For our first inequality, we have y is less than 1/2 x plus 2. So to graph this, I need to know the slope. And remember, my slope is just the number in front of x as long as it's in slope-intercept form, which it is. So the number in front of x is a positive 1/2. And then my y-intercept is positive 2. Always graph that y-intercept first. So positive 2 is the one I graph first. It's on the y-axis, so that means I go up 2 because it's a positive 2. Now my slope is positive 1/2, so my rise is a positive 1, so I go up 1. My run is a positive 2, so I go to the right 2. I have room, so I'm going to go ahead and do that again. Positive 1, up 1, to the right 2. We can also do the opposite. So to do the opposite, instead of positive 1, make it negative 1. Instead of positive 2, make it negative 2. So if my rise is a negative 1, we will start at the y-intercept and go down 1. The run is negative 2, so I go to the left 2. I have room, so I'm going to do that again. Down 1 to the left 2. Now, remember for inequalities, these are not always just lines that you graph. We have to determine if it's going to be solid or dotted. So looking at my inequality sign, there is no equal to bar, so it's going to be a dashed line. There's going to be holes in our line. Okay, so I'm going to connect my points with a dashed line. Disconnected line, just like that. Okay. We also must have shading for an inequality. Now, when you do your shading, please do so lightly, all right, because we're actually going to be looking for the space that the two inequalities have in common, so it would be really helpful to do this very lightly, okay? So what I'm going to do is, this is a less than symbol, so I'm going to put my person on my line and think, okay, if it's less than, if it's eating the equation, that means I shade the grass. I shade below the line. So the grass is down here. My suggestion would be just put a few lines like I'm doing, very spread apart, to show where it's shaded. Don't color it all in dark, okay? Because we still have another inequality to graph, and you need to be able to tell where this inequality is and where it's shaded, okay? So don't make it super dark, just enough where you can tell, okay, it's shaded below. I've got it. Now, when I'm doing a system of inequalities, I like to use two colors, all right? So I can see very clearly the first compared to the second. So I'm going to be using blue for the second. My suggestion would be use a different color, okay? If you need to use crayons, use crayons. If you need to use a pencil and then a red pen, that's fine. Just find a way to make sure that you can tell the difference between the two. So for the second inequality, my slope is negative 3 over 2. My y-intercept is negative 2. Graph the y-intercept first. So negative 2 means go down 2. Put a point. After that, my slope tells me the rise is negative 3, so I'm supposed to go down 3. 1, 2, 3. My run is a positive 2, so I go to the right 2. Okay, I don't have room to do that again, so I'm going to go ahead and do the opposite. So instead of negative 3, let's make it positive 3. Instead of positive 2, we make it negative 2. So positive 3 tells me to go up, 1, 2, 3. Negative 2 tells me to go to the left 2. Here's where they meet. Now, For an inequality, we're not just looking for where they meet, so keep going, okay? And I'll explain what we're looking for here in a minute. So positive 3, up 3, negative 2 to the left 2. Okay. So that's as far as we can go. Now, solid or dashed. Looking at my inequality sign, there's no equal to bar, so it has to be a dashed line. So I'm going to connect my points with a dashed line. That just means there's breaks in the line, okay? Not solid, dashed. There we go. And then I have to determine where we're going to shade. This inequality is greater than. It is eating the y. If it's eating the y, here's my person on my line. Stand like this. Eating the y, shade the sky. So to shade the sky, I'm going to shade up above, like this, ignoring the other inequality, shade above. Okay. Now, here's where it gets a little tricky. I told you we're looking for the place that they have in common. In an inequality, it's not just where they meet, okay? An inequality has shading that you have to think about as well. So for an inequality, we are looking for the two distinct places where the shading intersects, okay? And it might be a little hard to see, but this blue line is shaded up like this. So what I'm looking for is where my blue shading and my black shading cross, where they intersect, where they're both located. Now you'll notice there are 4 different sections of this graph that are created by the two intersecting lines, okay? This space right here is not shaded at all. That means it's not an answer for anything. This area is only shaded with my black marker. That means these are all answers, but only for this black line. There's no blue shading here, so it's not answers for the blue line. So these don't count, because it's only answers for one of the inequalities. I want answers for both. Looking up here, I'm only shaded for the blue line up here, okay? So these are not answers because they're only answers for this blue line, not for both. I want the answers for both. This section here off to the right, you should notice on your paper that that is where the shading intersects, where it crosses, okay? Both lines, blue and black, are shaded for this space and this space only. These answers, these points are solutions for both inequalities. So it's this area right here. I shaded in nice and dark because this is the only place on the graph that the answers are true for both inequalities. I need it for both of them, not just one of them. So I shade that area nice and dark. These are not solutions, there's no solutions here, and these are not solutions because this is only blue, this is only for the black, this area is for both. So that's where you shade dark, okay? So these are a little tricky because you have to figure out where the intersections cross, so be very careful of that. And that's why the two colors usually help, because then you can see a little bit easier when you see the two colors together. Those are where the answers are, okay? So that is our graph. That is our answer for problem number 1. For problem number 2, our first inequality, which is what we'll graph first, is x is greater than 3. Now remember, for these are the only ones you're allowed to start on the x-axis first, because that's the only variable we have. You must start on the x-axis, not on the y this time. So if x is greater than 3, we must go to where x is 3. Put our point. Also remember, okay, that anytime you only have x, no y, that means your slope is the undefined slope. So this is from previous lessons. So if you didn't know this, you might want to go back and check over that. All right, but if x is by itself, there's no y at all, that means the slope is undefined. Now remember, undefined is that vertical line, okay, going straight up and down. So I need to draw a vertical line for this. I need to figure out if it's going to be solid or dashed, Looking at my inequality, there is no equal to bar, so I know I should draw a dashed line. So I'm going to go ahead and draw a vertical dashed line right here, where x is 3. Now I need to do my shading, okay? It says x is greater than 3. Well, if x is 3 here, then to be greater than 3, we must go to the right, this direction. If we go to the left, our x's are getting smaller. 2, 1, 0, -1, -2, so forth. The further you move left, the smaller they get. I don't want smaller, I want greater. So greater numbers are off to the right, so that means all of my shading is going to be off to the right-hand side. All of these have x coordinates that are bigger than 3. So this is where I shade. There's really no grass or sky in this case because it's a vertical line. There's no standing up on top because it keeps going this direction. If I try to put my person, remember they just fall off. This is the undefined slope. So it doesn't really work like the other ones. So now you just have to think about pure numbers. Smaller than would be off to the left. The greater than numbers are off to the right. Okay? So that would be our graph for the first inequality. For the second inequality, we actually have a slope and y-intercept this time. So my slope is -2/3. My y-intercept is a +1. Graph the y-intercept first, +1. So we go up 1, put a point. My slope is -2/3, so that means -2 for the rise means down 2. +3 for the run means to the right 3. So we put a point right here. We can also do the opposite. Instead of -2, make it positive. Instead of +3, make it negative. So a +2 for the rise means up 2. A -3 for the run means to the left 3. Put our point. Then we look at the inequality sign. We have an equal to bar, so that means I need to have a solid line. So I'm going to connect my 3 points with a solid line and put arrows at the end, going in both directions. There we go. Now, this one I can put my person on and think about the grass or the sky. So, this is a greater than symbol. It is eating the y. If it's eating the y, shade the sky. So, the sky is above his head, so that's up here, above the line. That would all be the sky. Remember, ignore the other line right now. Just do your shading. Now, all of this shaded stuff is not answers. Only where it is shaded twice, where our colors intersect. Again, I'm using 2 colors for a reason. I want to be able to see very clearly where the 2 colors meet. In this area right here, I only see red. Down here, there's nothing at all. In this lower right-hand corner, it's just black. But here, the upper right is both black and red. This is where my solution is. These are my answers. So this area off to the right gets shaded in nice and dark. These are your actual solutions, okay? Not here because this is only red. Not here because that's only for black. Only here in between the 2 lines in this upper right corner, that's where you shaded in nice and dark. So those are our solutions for number 2. For problem number 3, our first inequality is y is greater than or equal to 1/2 x minus 1. First thing we need to know, the slope. Our slope is +1/2. Our y-intercept is -1, minus 1. Graph the y-intercept first. -1 means we go down 1. So I start at the center, count down 1, put a point. My slope is +1/2. So to graph that, my rise is a +1. I go up 1. The run is a +2, so to the right 2. Up 1, to the right 2. I run out of space, so let's go ahead and do the opposite. Instead of positive 1, make it negative 1. Instead of positive 2, make it negative 2. Start at the y-intercept again. A rise of negative 1 means down 1. The run is negative 2, so I go left 2. Down 1, left 2. Now, for the line, this has an equal to bar, which means my line must be solid. So I'm going to go ahead and connect my points with a solid line. Here and here. And then I need to shade. This is a greater than symbol, so if my little person is standing on my line, greater than means it's eating the y, so we shade the sky. So the sky is up above the line where he's standing, all up in here. So I'm going to shade it enough where I can tell that this is how it's being shaded for the first inequality. And that's our graph for the first one. I'm going to go ahead and take out my red and graph that in a different color so that we can easily tell the two apart. Okay, so my slope for the second inequality is a positive 1/2. So positive 1, positive 2. My y-intercept is a positive 2. Graph the y-intercept first. Positive 2 means we need to go up 2. So starting at the center, count up 2, put a point. My slope is positive 1 over positive 2. A rise of positive 1 means we go up 1. The run is a positive 2, so we go to the right 2, put a point. And we can do it again. Up 1 to the right 2. Now let's go ahead and do the opposite. Instead of positive 1, make it negative 1. Instead of positive 2, make it negative 2. So the rise is a negative 1, so I go down 1. The run is a negative 2, so I go left 2. Down 1, left 2. Now, my inequality sign has the equal to bar, so that means my line should be solid. So I'm going to go ahead and connect all of my points with a solid line. There we go, for the second inequality. Now, you'll notice already that these two lines are parallel. Now, for systems of equations, if the lines are parallel, you're done. There is no solution. But that's not necessarily the case with a system of inequalities. Equations, yes. Inequalities, no. So we need to go ahead and do the shading and see if the shading intersects. The lines don't have to. It's just the shading that needs to intersect. So let's check. This is a less than or equal to. So if I put my person on here, less than is eating the equation, so that's when we shade the grass. So the grass is down below the line, so that would be like this. Go ahead and shade it below the red line. All of these red, shading it below the line. There. Now, we are looking for the place where the black shading and the red shading intersect, where they meet, where they're both happening. If you notice, above the red line, it's only shaded in black. This is only black. So I'm going to go ahead and kind of erase that so you don't really see it anymore, because that's only one color. I want both colors. That's only one. Below, down here, this lower section is only red. So I'm going to go ahead and lightly erase that. I don't really need that. I want where they're both shaded, not just one. In between the two lines, you will see both black and red shading. Those are the solutions. Remember, it's where the shading crosses. So black and red both happen in between. So that's the space where I shaded in nice and dark. All of these points are solutions for both inequalities. Shading, shading, shading. All this part right in between. That's nice and dark. Okay, those are our answers, nowhere else. All right, so make sure you're paying close attention to where the two colors meet, because that's where the solution actually lies. At this point, go ahead and pause the video, work out problem number 4 on your own, and then come back and check your answer with mine. For problem number 4, the first inequality is y is greater than or equal to negative 1/3 x plus 3. So I went up 3 first. My slope was negative 1/3, so down 1 to the right 3. The opposite would be up 1 to the left 3. I drew a solid line because of the equal to bar, and I shaded above the black line, my first one, because it's greater than. Okay, eating the y, shade the sky. For the second inequality, I had y is greater than 1/3 x plus 1. My slope is 1/3, my y-intercept is 1, so I went to 1. I did my slope of positive 1/3, so I went up 1, right 3. The opposite is down 1, left 3. I made a dotted line because there is no equal to bar. The equal to bar is missing, so I made a, dashed line. So there are holes in my graph, all right? And then this is a greater than symbol, so that means shade the sky, so shade above. So all my shading for the red was above. I found that this top portion here was shaded for the black and for the red. This left portion is just red, this small right portion was just black, and the lower was not shaded at all. So the top portion was my double shaded area where the black and the red met. So I shaded that nice and dark. So my solutions are right up here in this top portion, nowhere else. So this should be your graph for number 4. And that's the end of our lesson on graphing systems of inequalities.